Okay, this video goes over the last predictive analytics topic, clustering analysis. And I'll let you do your own research on what that is and find some websites. And you should, in fact, I might even make that part of the homework assignment, is to go out and do a better understanding. I'm going to use an example to talk about what it is. And in this case, we've got some purchasing transactions by people and what they bought and how much they spent on that. And we've got, I think, 3,000 transactions. So for every one of these transactions, we know who bought it, as well as what they bought and how much they spent. And the key is that we want to cluster the customers. We want to group the customers into similar groups because we might want to do different marketing campaigns based on different types of customers. Or there's some customers that only buy athletic shoes, and let's focus on them and maybe offer them a coupon to something. So it's really learning how to group items into similar baskets or clusters or groups. So this is our transaction data. So here's the steps that you do. The first thing that we want to do is that we need to come up with the customer ID, and I think we have 250 customers, and count how many, we can do this either on the act of purchasing or we can do it on dollars amount. The example I'm going to go through is just how many purchases they made. So the first thing I did was build a pivot table from this, built a pivot table over here, and this is the customer ID, and this is, you can see this particular person, of those 3,000 transactions, they had 10 times that this person bought athletic shoes, they bought casual shoes a little bit, but they obviously bought those. And then you look down at this customer, and they bought work shoes. So maybe this customer is very different than this customer. And how do we group these customers based on purchasing data? So I used a pivot table to come up with the counts. Again, I'm not doing dollars. You could easily do dollar amounts on this as well. Then after we do this, then the heavy lifting happens in this third worksheet. And in the third worksheet, I brought the data. So this data is exactly the same thing as the pivot table. I just moved it over. Actually, I pointed to it. I used a formula. And then from this data, we standardize the data. And there's lots of ways to standardize. In this case, how we standardize is that we took this dollar amount, this purchase, and wanted to know, of all of the purchases that happened, was this a big purchase or not? Is 10 a big number? And so what we did is we took this number and we divided by the max of that entire column, and we showed it as a percent. And so we're getting a feel that that particular purchase of 10 is a high number. That's 83% of the max. So that doesn't happen very often. So that's kind of an important number. So when you standardize by taking every value and divided by the max of that column, you get a feel of what if that's a big number or not. So that's not that important, and obviously I never purchased those, but when you see a big number, something out there that's kind of big, then that's probably important, that person, that's a significant purchase. That's what it's telling us. So that's the first thing, is that we standardized, and there's lots of ways to standardize, but that's one way. The next one is the hardest part of the entire thing, is how did we calculate this? And what these are, we're going to build clusters, and we've got these 5 different purchases, and we need to come up with, we're going to use 2 different clusters. We're going to try to group customers either into cluster 1 or cluster 2. You can only be in one of these. So this formula, which is really ugly, is based on some theory. So this 0.71 is a distance. That's how you want to think of it, as a distance. So let's go over and look at this. Was a very simple 2-dimensional problem. If we had 2 points, we had this point and this point, the distance between these points is this formula. It's x2 minus x1 squared plus y2 minus y1 squared. And that's just analytics geometry. And you take that square root and that'll give you the length of that line. That's the distance. So we're going to generalize this when we have more than 2 data points. So what is happening here? This is the formula, and you just have to copy and paste it, but let's look at what's happening. What it's doing is taking this first customer, these numbers, and they get multiplied by, or they look at the difference between these and these values. So that's what's happening here. This is the difference between this value and this. And I'm showing it as percent, but it could be a whole number, I mean a real number. But I take that difference and square it. This is this difference and this difference, square these. And so I've got these differences squared. I add them up, and then I take the square root. And that number is what happens here with that formula. The sum xmy2 is doing this, and then we take the square root. So, and it's also, when I do this one, this one is going to be this times this. But when I do this one, it's going to be this times the second cluster. And what these are the centroids, are the middle of the cluster. So this cluster 1, these are the middles, the middle. So we have all of these different distances. And then we got to decide which grouping that this customer gets into. And we just do it based on which one is, which middle is the closest. So we have 2 clusters. That's, we're going to try to group these five purchases into 2 clusters, and you can see that customer 1 right now is closer to cluster 1 because this number is smaller than this one, so this customer gets grouped into cluster 1. And you can look down here, this number is smaller than this one, so this customer gets grouped into cluster 2. Okay, so what we're trying to do is group these into similar groupings. Now, these, we don't know what they are. These are the middles of these clusters, but we don't know what they are. When we first start, this is what we got, like that. And so what we're going to use is optimization. We're going to let the model decide what these are going to be. These are the centers in 5 dimensions, the centers of this cluster. And then these will be the centers of this cluster. So again, if it was 2 dimensions, it's real easy to understand. You would just pick X and Y, but this way we got 5 dimensions. The total distance then, the total distance is the minimum distance added up. And all we're trying to do is pick the minimum distance. We're trying to, these numbers will be selected to make this the sum of this as small as possible. Well, how do we do that? We use optimization. So if you go under Data, Solver, it's already set up for you. Well, we're trying to minimize this distance by changing these cells, T through X. So I'm changing these cells. I've only got 2 clusters. And then I've got to put some boundaries that these numbers need to be between 0 and 1. We're going to standardize this, so these numbers have to be between 0 and 1. Now, what makes this new is that this is a very unsmooth problem. When we use mins to grab things that make decisions and matches, when we use these functions, we've got a very unsmooth, so we're going to have to resort to the only optimization that we have that will work is this evolutionary. This one definitely won't work. This one won't give you very good answers, so we're jumping to a solution method that can handle unsmooth cost functions. So trying to make this as small as possible, but figuring out where the centers of these groupings are that will minimize the total distance. And this will ultimately drop each of these customers into a cluster. So when I hit solver, using this, it's not going to happen fast. Look what happens when you hit solve. Look down here at the bottom. It's starting to solve, but it's still running. It's trying to make this number as small as possible, but it's running this evolutionary solver. So it's going to run for a while. If it runs too long, then I'll edit out the video, and I'll tell you roughly how long it took right now. So there you go. I didn't edit anything. That took about 15 seconds to come up with an answer, and it came up with the solution. And this is what the cluster centers would be over these 5 different purchases, types of purchasing. And we've got 2 clusters. And this is what it is. And now every person is assigned to a certain cluster. Well, what do we do with that? We can go back to the original data, and I've got it, and I can now go grab this by doing a VLOOKUP of this customer over in this cluster by count. So it looks up this ID in this big matrix, and it looks up this ID and it returns this value, which is column 17 out. So now we've grouped, and now I know which grouping that's in. You can also draw a picture of this. This is a picture of those transactions, of this data, where we've got the 2 clusters and how many of these went into. So you can see the obvious differences is that cluster 2 is made up people that buy work shoes. Cluster 1 don't buy work shoes. So right now, if we only had 2 clusters, how we would really make the decision is that they buy work shoes. And then if you look at the dark blue, the second biggest driver is that cluster 1 primarily buy athletic shoes. So that's it. There might be other differences. You can see that reds are about the same, so they buy the same amount. It looks like cluster 1 buys more dress shoes, so it looks like they buy athletic shoes and dress shoes, and cluster 2 just focus on work shoes. So that's the example. So what you're going to do in the homework is a couple of things. Is one, you're going to can extend this problem, but you're going to increase the number of clusters from 2 to 3. Go to 3. Now, it's not going to take much to change. You're going to have to add an additional column here to get a 3rd cluster, like that. So you're going to have to write a formula here that will do these. And then on solver, you're going to have to select that next row down, so row 5. This is already set up. It's minimizing everything, so you're good there. And you can, and if you do that, you can do analysis. What if we could categorize these into 3 groupings instead of 2 groupings? So that's going to be one of the homework problems. The other one is that you're going to do the exact same thing, but rather than looking at counts, you're going to look at dollars amount. So we're going to look at not based on how many things they bought, but the total dollar amount. And all you have to do is do this exact same thing, but instead of doing counts, you bring in the dollars spent, like that. And then that would be a dollar amount. And you can go through the same thing. Okay, hopefully that video gives you a good start on how to do clustering analysis.